everyone. So in our last two videos, we talked about a type of transformation called a shift, right? We took our graphs and we basically moved them left or right or up and down. And we didn't change the shape of the graph. Rather, what we did is we just took the graph and literally kind of picked it up and moved it, again, either vertically or horizontally. And so in this video, we're going to be talking about another type of transformation called a reflection, or another word for it will be a flip. So we're basically going to be flipping our graph either over the x-axis or the y-axis. So I'm going to approach this similarly to how we did in the first video about transformations. So for this first couple examples, we're going to make tables to help us kind of understand why the transformation works the way it does. Once we've established, how the transformation works, then we're not going to make tables anymore. Then we're just going to kind of apply the transformation just by recognizing what it's going to do to the graph. Okay, so the function we're going to be working with as our kind of basic beginning function in this video is going to be the square root graph. So I want to start by just filling out this table for f of x is equal to square root of x, and then we're just going to sketch the graph. So as always, and I think especially for these two examples, I think it will be helpful for you if you pause the video and try to do things yourself the most that you can. I think that'll just help you get a little bit more out of understanding why these things work the way they do. So, okay, so we're filling out this table first just for the square root of x. So square root of 0 is 0, square root of 1 is 1, square root of 4 is 2, and square root of 9 is 3. So I'm just going to go ahead and plot those points. We have the point 0, 0, the point 1, 1, the point 4, 2, and the point 9, 3. And so if you remember, a square root graph basically looks like half of a sideways parabola. Okay, so the first transformation we're going to do is we're going to apply a negative sign to the function. And so just like with shifts, there's this distinction between, are you applying the negative sign to the function as a whole or to x? So just to give you a quick preview, the next example we're going to be applying the negative sign to x. In this example, we're applying the negative sign to the entire function. So first step is to kind of rewrite that function just as a normal formula for a function, right? So that we're not kind of expressing g of x in terms of another function. We're just going to kind of write down like a normal formula for it. So if f of x is equal to the square root of x, what would negative f of x be? Well, it would just be negative square root of x, right? It's basically just the negative of our original function, and our original function is square root of x, so we have negative square root of x. So let's go ahead and fill out this table. So on this table, we are, just to kind of explain how these numbers get plugged in, you're first taking the square root of these numbers, and then you're making the result negative, right? So 0 is kind of a exception to that because 0, the negative of 0 is still 0, so that just stays 0. But for example, if we plug in 1, we take the square root of 1 and we get 1, but then we have to add a negative sign, and so we get negative 1. Similarly, if you plug in 4, the square root of 4 is 2, but then we have this negative sign that we have to apply, and so we get negative 2. And then if we take the square root of 9, we get 3, we apply the negative sign, we get negative 3. So I'm going to go ahead and plot these points, and I'm just going to do it all in the same graph for this one. So we have 0, 0 still, then we have 1, negative 1, then we have 4, negative 2, and then we have 9, negative 3. And so our graph looks like this. So how would you describe what happened here? Well, our graph was reflected, right? It was flipped. And I think there's kind of two ways to describe this flip. I'm going to write it both ways. So I would say one way of describing it is that the graph was reflected vertically. So what do I mean when I say reflected vertically? Well, if you were to motion with your hand which way it got reflected, you're kind of moving up and down, right? the important thing is what changed here. It's the y coordinates that changed, right? Not the x coordinates. So in that sense, the flip is kind of going, it's affecting the graph vertically, not horizontally. But another way that we could describe this reflection is we could say that it was reflected over or about the x-axis. And that might seem a little counterintuitive to you, that like vertically would mean about or over the x-axis. But if you think about it, it kind of makes sense, right? If the x-axis is what we're flipping over, well, that means that it's the y coordinates that are getting changed. So it's actually a vertical reflection. So why did this happen? We can see in the graph what happened, but if we look at our tables, let's try to understand why did this cause the graph to flip over the x-axis? Well, if we look at the x-coordinates stayed the same, right? For the points that we were focusing on, the x-coordinates were all the same. So what did change was the y-coordinates, right? The y-coordinates for the original function, the y-coordinates were all positive. But what happened here was that we added in this negative sign, right? And so we had negative square root of x. And so what ended up happening is that all of the y-coordinates became negative. And so if you think about it, if the x-coordinates stay the same and the y-coordinates become negative, that's just going to take your whole graph and basically kind of flip it upside down, and specifically flip it over the x-axis. And another thing to notice is that the point that was originally at 0, 0, it stayed at 0, 0. And so why is that? Well, basically that point was already on the x-axis, right? So if a point is already on the x-axis and you try to flip it over the x-axis, it's going to stay exactly where it is. Or another way of thinking about it is that you can't if you try to make 0 negative, it stays 0. So all these other numbers, when you negated them, when you added that negative sign, they became negative, whereas 0 stayed the same. So that's why that point didn't go anywhere. It stayed in the same spot. Okay, so that is a vertical reflection. So let's see now what happens when we, instead of putting the negative sign on the outside of the function, now we apply it to x itself. So we're affecting the input rather than the output. So I'm just going to fill out this table again real quick and sketch our graphs for the original function. So 1, 1, 4, 2, and 9, 3. So there is our original function. Okay, so now let's rewrite this function f of negative x in terms of just kind of normal function formula, right? We don't want to be expressing it in terms of f of x, we just want to write it down as like a function. So if our original function is f of x is equal to square root of x, what is f of negative x? Well, that would be square root of negative x. Right? No matter, like anytime you're evaluating something that looks like this, you're just replacing in your original function, you're replacing x with whatever is inside the parentheses. And so if our original function was square root of x, instead of taking the square root of x, now we're taking the square root of negative x. So that might seem a little weird to you, right? Because we're not supposed to take the square root of a negative number, right? Like that's not allowed. We talked about that in the domain section. And so it's actually okay. It will change which types of numbers we're allowed to plug in. And so that's why you might notice that on the table I made, the inputs are all different, right? On our original table, the inputs were 0, 1, 4, and 9. On this one, I put 0, -1, -4, and -9. And so why did I do that? Well, because we're trying to take the square root of negative x. And so if you, for example, this would not work. Let's say that you tried to plug in like +4, right? If you tried to plug in +4 into the function, you would get the square root of -4, and that is undefined. So that would not work. So what do we need to do instead? Well, we need to plug in negative numbers, right? So if we instead plug in -4, well, then we'll be taking the square root of -4. And the way that negatives work is that two negatives multiplied together give you a positive, and so you end up with something that is okay. And so that's the reason that the inputs have to be negative numbers in order to basically cancel with the negative that is already inside the square root. Okay, so if we plug in 0, negative 0 is still 0, square root of 0 is still 0. If we plug in negative 1, we get the square root of negative negative 1, which is the square root of 1, which is 1. If we plug in negative 4, as we just saw, we would have the square root of negative negative 4, which is the same as the square root of 4, which is 2. And finally, if we plug in negative 9, we have the square root of negative negative 9, which is the square root of positive 9, which is 3. Okay, so let's go and plot these points. We still have 0, 0. We now have negative 1, 1. We have negative 4, 2. And we have negative 9, 3. And so again, we can see that our graph got flipped, right? But this time, or reflected, but this time, instead of reflecting vertically, instead of the y coordinates changing, this time it reflected horizontally. So this one reflected horizontally, or we can also describe that as a reflection about the y-axis. So in this case, the y-coordinates all stayed the same, and it's the x-coordinates that flipped sign. And so that causes us to have this horizontal reflection. Or again, you can think of it as reflecting over the y-axis. Okay, so let's fill out a table like what we did in an earlier video, so that we can describe in general what happens with these types of functions. So the first one we did is we applied a negative sign outside of the function. And so what did that do to the graph? Well, it gave us a vertical reflection. Or you could call it a reflection about the x-axis. So reflecting over the x-axis, we can think of that as being a vertical reflection. And then on the other hand, if you have the negative sign on the inside, if instead of negating, so sometimes we'll use the word negate, that just means to multiply by -1, to basically flip the sign of something. So if instead of negating the function as a whole, we're negating just x, the input, that is instead going to be a horizontal reflection. And another way of describing a horizontal reflection is saying that it reflected about the y-axis. Okay, so how do you actually do these on the graph? Well, what we saw is that when you do a vertical reflection, so when you're reflecting about the x-axis, basically what you're going to do is you're going to flip the sign, or I'll say it that way. You're going to flip the sign of every y-coordinate. The x-coordinates will not change their sign, but the y-coordinates will, because that's really what the negative sign is being applied to. And then for a horizontal reflection, instead you're going to flip the sign of every x-coordinate. Okay, so I want to do a couple more examples. I'm not going to do a ton of examples in this video, but I will give you some more to do on the worksheet that goes with this video. So I wanted to do a couple of examples where we don't have a formula to work with, where we're just given a graph and we just have to sketch the reflection of that graph. So in this first example, we're going to use transformations. We're going to sketch the graph of negative f of x. So again, we don't have a formula to work with here. Really, we just have to think about, what is the transformation and what do we need to do to this graph in order to accomplish that. And so here we see that we have a negative sign outside of the function. And so that tells us that it is a vertical reflection. Or as we said, another way of describing that is that we're reflecting about the x-axis. And so what is that? How can we actually accomplish that? Well, we basically just want to flip the y-coordinate of every point. So I'm just going to pick out, this is the same graph that we used in an earlier video. I'm just going to denote like a few points on here that we can focus on, and then we can just kind of connect the dots between them. Okay, so what I want to do is for each of these points that I kind of bolded here, we're going to keep the x coordinate the same, but we're going to change the sign of the y coordinate. So for example, this first point all the way to the left has coordinates -1, -1. So if we keep the x coordinate the same and change the y coordinate, that should be now -1, +1. Okay, our next point is 0, 1, and so that should become 0, -1. Our next point is 2, -3. That should become 2, +3. Our next point is 4, 1. We want to make that 4, -1. Our next point is 6, 1, and so we want to make that 6, -1. And then our last point is 8, 3, and so that was going to be 8, -3. And so now we just want to connect these and just kind of try to mimic the same shape. So we know that our original graph has this kind of parabola type shape. So I'm going to try to do my best to give it that same shape. Then we have this horizontal portion and then a line again. And so that graph in green is the graph of -f of x. Okay, you can probably guess what's next. Next, we're going to sketch the graph of f of -x. Okay, so in this case, if we are putting the negative sign now not on the function as a whole, but on x, that tells us that we are going to do a horizontal reflection. Or we can think of it as a reflection about the y-axis. And so what is that going to look like? Well, we're going to keep all of our y coordinates the same, and we're going to flip the x coordinates. We're going to change the sign of the x coordinate on every point while leaving the y coordinate the same. So again, let's kind of go through point by point and just focus on leaving the height, leaving the y coordinate the same, and just flipping the x coordinate. So for example, this first point all the way to the left has a coordinates of -1, -1. And so we're going to change that to being now 1, -1. So we made the x coordinate positive, left the y coordinate the same. Okay, next point is 0, 1. Well, if you try to change the sign of 0, it stays 0, right? So this point is going to stay as it is because the y coordinate is not changing, and then the x coordinate is also not going to change because it happens to be 0. Our next point is 2, -3. And so that one is instead is going to be -2, -3. Next point is supposed to, or on the original function is 4, 1. And so now it's going to be -4, 1. Then we have 6, 1. And so that's going to be -6, 1. And then we have 8, 3, and that's going to be -8, 3. So just leaving the y coordinates the same, flipping the sign of the x coordinates. And so now we go through and connect things and just try to keep in mind the shape of the graph. So the first portion was this kind of linear piece, right? And then the next portion should have this parabola shape. So I'm going to go down and do that. And then the next part is horizontal, and then we have this last linear portion. And so there we have reflected now horizontally. So vertical reflection, horizontal reflection. Okay, we're just going to do one more example in this video. Like I said, I would really encourage you to look at the worksheet to get a little bit more practice. There's just not so many different examples we can do, and so I want to make sure I leave some of them for you to really try yourself. So in this example, what I want to do is use transformations to sketch. So I want to sketch g of x is equal to negative square root of negative x. So what's going on in this case? Well, this time we actually have two negative signs. And it might be tempting to think that they cancel each other out, but they actually don't in this case. And the reason is that one of them is inside the square root and one of them is outside. So they don't really interact with each other. So what's going on here is basically that we have two different transformations, right? In this case, we have both a vertical reflection. So we're going to reflect the graph over the x-axis, but we also have a horizontal reflection. So we're also going to reflect it over the y-axis. So I'm going to start by sketching the kind of original function here, which would be, so the basic graph that we're kind of comparing this to would be f of x is equal to square root of x. And so I'm going to start by just sketching that graph. Okay, so here is our original graph. And so there's a couple ways to do this. One thing that you could do is you could do each of the reflections one at a time. So you could start by taking the original function, reflecting it one of the two directions, and then take that graph and reflect it again. Personally, I think it's a little easier to do it all at once. So if you remember how we actually go about graphing these reflections, we do them by flipping the signs of the x and the y coordinates. So if we're doing both a vertical reflection and a horizontal reflection, that means that we're going to need to flip the sign of all the y coordinates, but then we're also going to need to flip the signs of all the x coordinates. And so we can really do that at once because, again, it's kind of this process of focusing on just these few points, and we can just flip the signs of both the x and the y coordinates and then connect the dots for our new graph. Okay, so the first point is 0, 0. So 0, 0 is not going to change, right? Because when you try to make 0 negative, nothing happens. It stays 0. Okay, so next we have the point 1, 1. So if we flip the sign of the x coordinate and the y coordinate, we get negative 1, negative 1. Next up we have the point 4, 2. So if we switch both the x and y coordinate, we get negative 4, negative 2. Oops, I didn't do a great job of plotting that. Then we have 9, 3. So if we switch both the x and y coordinate, we get negative 9, negative 3. And so if we connect the dots on our new graph, we can see that it looks like the same shape as the square root graph, but it's both upside down and facing the other way. So we've done a reflection in both directions. All right, so that is it for this video. In our next video, we're going to be talking about doing stretches and compressions of graphs horizontally and vertically. And then in the next video after that, we'll basically just kind of review all of the different transformations and also talk about applying more than one transformation to a graph. So we'll do examples where maybe you reflect a graph and you shift it, or you stretch it and reflect it, things like that. So I'll see you all in the next video.